So to perform auditory working memory tasks, we not only need to maintain information, but also need to use the maintained information to guide our decision and behavior. This readout phase has received relatively little attention in the field. So to study neural correlates of this working memory readout, we trained our monkeys to perform a delayed match-to-sample task on sequences of two sounds, S1 and S2 separated by a very short delay period. Monkeys had to make a go response if S1 and S2 are identical, and to make a logo response if they are different. So to solve this task, they need to hold information about S1, maintain information about S1 during the delay period, and then compare this maintained information with S2 to decide whether to make a go or a logo response. We recorded spiking activity of individual neurons in primary auditory cortex and also in the ventral lateral part of prefrontal cortex. But we know that actually these two brain areas are affected by many task components. For example, reward anticipation and motor execution. So to control for these potential confounds, we also trained our monkeys to perform a second task. So this second task is a S2 discrimination task. So in this control task, S2 could be a noise burst, a 20 hertz or 80 hertz click chain. So monkeys have to make a go response when S2 is a noise burst and a logo response otherwise. Therefore, they don't need to maintain information about S1 during the delay period. Also, they do not need to compare S1 with S2 for making a correct response. So these two tasks therefore differed in the demand of auditory working memory. So we found that many units had different firing rates, spike rates during the delay period between these two tasks. Some neurons had a higher spike rate in the working memory task, but some other neurons showed an opposite pattern. They had higher spike rate in the control task. In total, these neurons were about 1/3 of all recorded units, and they were involved in maintaining information during the delay period. But so what? So how was this maintained information transformed into a behavior response? So one idea is that, okay, it biased the responses, these neurons' responses to S2 during the readout phase. So to test this idea, we therefore compared this neuron's response to S2 between two conditions. So when S2 matched S1, and when S2 differed from S1 in the working memory task. And indeed, we found that these neurons, the responses to S2 were surprised when it matched S1. And this is the case for both auditory cortex, shown in the top row, and also in the prefrontal cortex, shown in the bottom row. So is this match suppression really behavior related, or is it simply due to stimulus repetition? So to disentangle these two possibilities, we analyzed error charts. Specifically, we compared this spike response to S2 in false alarms, in false alarm trials and in missed trials. And we found that actually this match suppression was reduced in error trials compared to correct trials. So this indicates that this match suppression we observed in these two brain regions is not due to stimulus repetition. It's rather related to the monkey's behavior. But which behavior component is this was related to this match suppression? So for this, we actually directly compared responses between correct and error chairs. So let's go to auditory cortex first, shown in the top row here. So in auditory cortex, spike response to S2 in false alarms almost overlapped with those in correct match chairs. This indicates that actually this spike response to S2 was surprised when the monkeys decided to make a go response. So in the logo chairs, these responses in misses also became similar to those in correct match chairs. So this findings, these results indicate that actually the match suppression observed in auditory cortex was related to monkeys' decision whether to make a go or a no-go response. This relationship was also observed in prefrontal cortex, as shown in the bottom row, and in this region. The responses in the two types of logo chairs almost overlapped, and also in the two types of go chairs, the responses become similar. In summary, so we found that neurons in auditory cortex and in prefrontal cortex, especially those involved in maintaining information during the delay period, surprised their responses to S2 to S2 when it matched to S1. Here is a sample tone, and this match suppression was behavior related and reflected the monkey's decision regarding whether to make a go or a no-go response. And all results indicate that both auditory and prefrontal cortex are involved in reading out the information maintained in working memory and then transforming the information into context-appropriate actions. Thanks for your attention.
Time for one question. I have a sort of minor question. Mm-hmm. You do, in auditory cortex, you expect to see repetition suppression. Mm-hmm. Okay, so you claim that when there's no behavior, there's no repetition suppression in auditory cortex?
No, actually we have passive data. The same system we will also present to the monkeys when they did not perform any tasks. We observed match suppression there, even in the passive condition, but we claim now here that actually, but it's in the very earlier component. But the later response to S2 is behavior related. I do not show that part of data here, but we have that data.
Okay, thank you. Okay.